In this video, we're going to look at the relationship between parallel lines and also the relationship between lines that are perpendicular to one another. So let's say that we have a line. Let's say, for instance, we have the line y equals 2/3 x. Okay. 2/3 x plus 4. So if I graph that line, and I'm going to go ahead and graph this one in blue. I would go up to 4. Since it's already in slope-intercept form, the easiest thing would be to go up to 0, 4, my y-intercept. And then look at my slope, 2/3. That means I go up 2 units and over 3 units. And I have another point, and I can draw my line. And then let's say I have a different line. Let's say that I have y equals 2/3 x plus, actually let's do excuse me, minus 2. So on this one, I would go down 2 units to my y-intercept, and then I would go up 2 units and over 3 units, and I would drop that point. And I can draw that line. And notice the relationship between these two lines. These are parallel lines. Every point goes up and over at exactly the same rate. And that's because the two slopes, m equals 2/3 here and m equals 2/3 here. So anytime two lines have the same slope, they will be parallel lines. All right, let's look at another line. Let's say that we have the line y equals -3/2 x plus 1. So on this line, my y-intercept is 0, 1, so I can plot that one. And then I'm going to go down 3 units because of the minus 3. I'm going to count down 3 units and then over 2 units. And if I draw that line, notice the relationship of that line to the other two is that it's perpendicular. I have a right angle between each of those. My slope on this one is -3/2. Notice the relationship between the number -3/2 to the number 2/3. I have flipped the fraction over, that's called a reciprocal, and I have also changed the sign. If this was positive, then this would be negative. So what we see is that perpendicular lines have negative reciprocal slopes. So I'm doing two different things. I am flipping the fraction over for the reciprocal, and I am changing the sign. Now watch out for this word negative. If I have a slope that is -1/2, and I want to find a perpendicular line, slope of a line that is perpendicular to that. I'm going to flip the fraction over, which gives me 2 over 1, which is just 2. But I'm also going to take the negative of the negative. So a negative of a negative is positive. So my slope of my perpendicular line would be positive 2. So when it says negative, it doesn't mean that the answer is negative. It just means that you're changing your sign. Let's see how this can be used to find some equations of lines. Let's say that I want to find the equation of a line through the point -2, 7 that is parallel to the line (2x minus 5y equals 11). Now remember from our lesson on finding equations of a line, when I'm saying find the equation of a line, that means that my answer is going to look something like this, or like this, depending upon if I want it in y equals mx plus b form, the slope-intercept form, or in standard form. So this is where I'm headed. To write an equation in either form, I need 2 pieces of information. I need a point, and I need a slope. Well, notice that I've been given a point here, -2, 7. So I have that. So I need to find a slope. I'm given some other line. This isn't the line we're looking for. This is some other line. But I know that my line is parallel to this line. So I know that my line has a slope that is the same as this line, because parallel lines have the same slope. So I need to find the slope of the line 2x minus 5y equals 11. And to do that, I need to get it into y equals mx plus b form. So I'm going to have you do that. Isolate y, get it into y equals mx plus b form, and identify the slope of this line. Pause the video, do that work, and then check back. All right, so if I'm looking at 2x minus 5y equals 11, and I want to solve for y, first thing I'm going to do is subtract the 2x. And I'm going to go ahead and put it in the front, because I know I'm heading for y equals mx plus b form. Then I need to divide everything by -5. And notice that I am doing this with the -5 separately rather than drawing just a big line with one -5. That makes it easier for me to see what my slope is. This is y equals mx plus b form. So that tells me that my slope is 2/5. So the slope of this line, and I'm going to call this M1, M sub 1, that just means the slope of this first line. So now I have the slope of the line I'm looking for, this second line that I'm trying to find. Because the two lines are parallel, my slope is also 2/5. So now what I'm doing is I'm finding the equation of a line. Through the point, including the point, -2, with slope 2/5. And we learned how to do that in a previous video. So I want you to pause the video, find this equation of this line, and let's go ahead and write our answer in slope-intercept form. But you go ahead and do that, and then turn the video back on and check your work. So I see I can use my point slope formula. This is my x1, this is my y1, and I'm given my slope, so I plug all of my numbers in. And minus -2, watch my signs here. I have y -7 equals 2/5, x plus 2. So I distribute the 2/5. And remember, when I multiply a fraction times an integer, I just multiply the numerators with and the denominators the understood 1. And then I add my 7 to both sides. So I have 4/5 plus 7, and remember I need to get the same denominator. So I have 4/5 plus 35/5, and 4 plus 35 is 39/5. So remember what we were trying to do here. We were trying to find an equation of a line. So we needed something that looked like this. And that line had to be parallel to this, have the same slope as this, and be through this point. And that's exactly what we have found. And this is our solution. Notice that my slope is the same, but my y-intercept is different. My y-intercept is different because they are not the same line. All right, suppose now that I want to find an equation of a line that is perpendicular to the line. And I'm just going to use that same line that we used in the previous problem. The line 2x minus 5y equals 11. And I'm going to go ahead and use the same point through the point -2, 7. Well, we've already found the equation, or excuse me, found the slope of this line. We already found that m1 was 2/5, and we did that by getting it into slope-intercept form. And then we saw that the line we were trying to find, line 2 here, had that equation. We're finding yet a third line. And because our third line here is perpendicular to that first line, I know that its slope is a negative reciprocal to this. So that means I flip the fraction over, and I also change the sign. Because this one was positive, this one will be negative. And so now I'm going to do the same thing. I'm going to find an equation of a line with the point -2, and the slope -5/2. And again, I want you to do that work. Pause the video, find the equation of that line, and write it in slope-intercept form. And then start the video back and check. So I use my point slope form, and I plug in my numbers. This is X, this is Y. And we already saw that minus -2 is X plus 2. And now I distribute the -5/2. And minus 5/2 times 2, I multiply the denominators, keep the numerators and the denominators, the 2 times the understood 1. So I have -10 over 2. And I see that that actually simplifies. Two minus 5, because 10 divided by 2 is 5. I could have also, if I had done it like this, I can see that my 2's cancel and I just get -5. So now I can add my 7 to both sides. And -5 plus 7 is plus 2. And this is the equation of my perpendicular line. And notice that it has yet again a different y-intercept because it is a different line, and the slope is a negative reciprocal to the previous 2 parallel lines.